Section 3.1 Interactive Assignment, Objective 1. We want to determine the arithmetic mean of the variable from raw data. The following data represent the pulse rates, beats per minute, of 9 students enrolled in a statistics course. Treat the 9 students as a population and then complete parts A through C. So here are the 9 students and there's your pulse rates. The first question says determine the population mean pulse. So let's take a look at that here. In order to do that, what we'd have to do is we're going to have to total up the entire values. So that means if we look at the pulse rates here, so this is all the total. So that means we're going to add all of those. So we're going to add up all of these values in the numerator. So this represents the sum of 89 plus 85 plus 89 plus 78 plus 69 plus 72 plus 74 plus 83 plus 76 gives us 715. Okay, and then we're going to divide by the total amount of values that are in there. You can see here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to divide that by 9. So 715 divided by 9 is going to give us 79.4. And let's go ahead and just take a look at this on our calculator to make sure, because we're rounding it to one decimal place. If we take 715 and then divide that by 9, we get 79.4 rounded to one decimal place. Okay, so we're going to put on our answer, and we can see that the population mean pulse is approximately 79.4 beats per minute, and we round that to one decimal place as needed. Now in part B, it says determine the sample mean pulse of the following 2 simple random samples of size 3. Sample 1 is Jeff, Clarice, and Kevin, and sample 2 is Megan, Perpetual, and Jeff. So let's go ahead and take a look at that. So for sample 1, okay, we know that we have Jeff, Clarice, and Kevin. So what is the value for Jeff? Well, we know that it is 89. Excuse me. We know the value for Clarice is 78, and the value for Kevin is 74. So we're going to add those up, which is going to give us 241, and we're dividing it by 3 since that is the total in the sample. So if we take 241 and then divide that by 3, that gives us 80.3 rounded to one decimal place. Okay, now let's take a look at sample 2. Well, sample 2 represents Megan, Perpetual, and Jeff. Well, Megan had a value of 85. Perpetual has a value of 89, and then Jeff has a value of 89. When we add those together, we get 263, and we're dividing it by the sample size of 3. So if we take 263 and then divide that by 3, we get 86.666667. Rounding this to one decimal place gives us 87.7. Okay, now the last question asks the following. So again, here is our 80.3, 87.7. So in part C, it says determine if the means of samples 1 and 2 overestimate, underestimate, or are equal to the population mean. Okay, so let's write out our symbols, okay, because I think it's important to understand what is the symbols for each of these. Now, this is the population. So the population mean is mu, which is equal to 79.4. Okay, over here we have sample mean 1, which is going to equal 80.3. Now the sample mean is x bar, and then this is going to be the sample mean 2, which is x bar, which is 87.7. So in this first example, we're going to take the sample mean of 1, and we can see that it's going to be greater than the population mean. So again, taking a look at the population mean, we know that that is 79.4, and we know that the sample mean is 80.3 for sample 1, and therefore since it is greater, then we overestimate. Okay, next we're going to take a look at sample 2. So does sample 2 overestimate, underestimate, or equal? Well, we know that the sample mean of sample 2 is given by 87.7, and we know that the population mean is given by 79.4. So when we compare those, we say that the sample mean for sample 2 is greater than the population mean. So therefore, our answers are overestimate for both of them. So therefore, we would say that mean pulse rate of sample 1 overestimates the population mean, and the mean pulse rate of sample 2 overestimates the population mean.